Hello everybody, today I will talk about ASVAB electronics information. In here, I will show on the topic that we will have on the test and we need to learn from A to Z in here. So I will show for you. First, we will learn about the circuit, voltage, current, resistance and load, units, conversion. In here, units and conversion, they will go together because they will be on the test, and they ask about how to understand about conversion and the units. Ohm's law, symbol, series and parallel. In the series and parallel, I will show how can calculate about the ohm, current and voltage. DC and AC, routing, power, measurements, digital watt-hour meter, conductive materials, standard voltage hertz, that's it on in America, insulator, inductor and capacitor. In here, inductor and capacitor, I will show you how to calculate the resistance of hertz, because this one will be on the test and they ask you how to understand about inductor and capacitor. Diode, transistors, transformer. In transistor and transformer, I will show you about the difference and what is the transistor and transformer too. This thing will be on the test and we need to learn how to do about transformer. We need to convert the high voltage to the low voltage. The next one is about colors of wire. It means that the hot wire, what kind of color of the hot wire and what kind of color of the routing wire. And the last one is about color code of capacitor and inductor. So on the ASVAB electronic information, we will learn all of them because this is so important how to pass the ASVAB electronic information. Hello everybody. So what I will explain what is the circuit. So in the test, they will ask about the closed circuit and open circuit. And we know that in the closed circuit, it means they are closed loop to carry the electron. It means that in the closed circuit, they don't have any break in the series or break on the wire, so that they can carry the electronic back to the positive. For example, here this is the closed circuit, and we know that the small one is the negative and the long one this is the positive. And in the closed circuit, the electrons they will go through to the wire. This means that this is the closed circuit. They go through from negative to the positive. And in here, we can see that that is the basic closed circuit, and we need to know about that. Let's see about the load. I will talk about the load later. About the open circuit. This means that they are not connected to the power in here, so that they maybe they can break the wire. For example, I will show for you. This means that this is about the switch. You can see that there are open, therefore the circuit they don't connect in the same. That's why when the electron they cannot go through back to the positive side, so that there is no electron. Therefore, there is no current and the volt. I will show the current and volt later. Therefore, if the test asks if we open the circuit, so do we have the electron? So the answer is no electron, no current, and no volt. The next one is about the current, and we just remember that the definition of current is a flow of electrons. I will show you. Here, this is the closed circuit. In here, I just zoom out a little bit. This is the small tiny in the wire, and inside the wire there are so many electrons that flow from inside the wire, and you can see that electrons just go in the same flow, and this is why we have the current. Of the volt, so the definition of the volt is about the push to the flow of the electron. This means that the volt, just like the force, they push the electron, they go to the inside the closed circuit. And in this one we have 3 types of names. So on the test, if they see the volt, they will show you about 3 different types of names. So that we have 3 types of name of the voltage. That's a electromotive force, because they have the force to push the flow of electrons. Electrical pressure, just the pressure in here, just like the force. Electrical potential, they have 2 potential because they have the force to move the flow of the electrons. That's why we have the electrical potential. Without electrical potential or the voltage, the flow of the electrons, they cannot move. They will standing on the wire, and they cannot go anywhere. One, I will talk about the load, because in the load we cannot have the definition. The load, we can say that's about the consumption of the electron or the consumption of the power. For example, Let's see the closed circuit, and we see that the electron they go through inside the wire, so that the light they will shine. And this is about the load. And another example. This is about the load, and we call this about resistor. Or sometimes they can write like this. It means that on the light, the resistor and the resistor another symbol, they have same meaning. They consume the electrons or they consume the power in the closed circuit. Everything is about the load. In here, let's see on the, we can say about the opposite of resistance. It means they don't want to the flow of electron go through fast. They just reduce the speed of the flow of the electron. For example, we have the electron in here. You see that in here we have so many electrons on the left side, and the right side we have many field, because the resistance in here they restrain a lot of the pressure of the electron, because the voltage in here they just push in here, they just resist. This means that if we don't resist about the flow of the electron, the power, this means the battery in here, they will explode. That's why we need to have the resistance to reduce the flow of electron or the power in here. They will explode because too many electrons hit to the positive area. That's why we call them this is short circuit. It means that if too many electrons and we don't have some resistance, we can create a short circuit. For example, this is about the closed circuit, and electrons they go through on the wire until they hit about the positive side of the battery. If too many electrons hit to the battery, they will increase more the heat. Too many heat go up. That's why the battery will explode and we can create a short circuit. Therefore, the resistance in here is the good mission is reduce the push and reduce the flow of the electrons. In the next one, I will show the picture how to explain about that. In the units, we just learn about understand the current, the voltage, resistance, and the power. On the test, they will ask about what kind of the unit related to the current, voltage, resistance, and power. And I just show all of them. When we do the practice, we will use I, VI for the current, V for the voltage, R for the resistance, and P for the power. On the units, we have that on the current we have capital A, AMP, C over S, that's about coulomb per second. This means that every 1 second we have how many electrons that go through in 1 second. About the voltage, we have V. The next unit is about N multiplied with M divided by C. So in here we have Newton multiplied with meter divided by Coulomb. It means that the Newton is about the force, because the voltage is the force to push the flow of the electrons. So that we have Newton multiplied with meter divided by Coulomb, and we have abbreviation is about capital N multiplied with the small m divided by C. And this is the voltage. This is so important. The next one is about resistance. We use the capital R. In here, this is about ohm, and we use about this signal, and we can write this later. We can use ohm like this signal. The next unit of the resistance is about V divided by A, and in here that's about the volt divided by IME. I will explain why we use the volt divided by IMB. The next one is about the power. We have capital P, and the unit to use the power, that's about watts. And the next unit of about the power, we use joules divided by second, because the power just like the energy, and we use the joule just like the heat. And every 1 second we receive how many power, that's why we have joule divided by second. And you need to understand and memorize on the units, because they will ask about different kind of units to convert to the current voltage. This is our inductor and capacitor. In the inductor, we have about the henries. We use the capital H. And about capacitor, we use farad. That's the F. And we need to learn about Henry and farad. We ask, what is the units of voltage? We have A is A, P is about Newton multiplied with meter per Coulomb, C is about omega, D is about voltage divided by second. So the question they ask about the voltage, and they ask about the unit. So the answer for this question is about B. On the test, they will ask in the current, what is the units per second? So we have A is about joule, B is about Newton, C is about Coulomb, and D is about Henry. We know that the current in here, that's about ampere, and in the ampere we have about coulomb per second. This means how many electrons that go through in the 1 second. So we have coulomb per second, and the answer for what's the unit per second is about C. In the voltage, what is another name of the voltage? We see that in the voltage we have 3 types of name. In here we can see that we have electronic potential, electronic pressure, electromotive force, and in the answer key, the answer for this question is about A, because this is about the correct name of electronic potential, but the flow of the electrons is about the current, be careful with the question like this. So the next question is about real ASVAB. Electrical pressure is also known as, we have A, ohms, B, voltage, C, charge, D, conductivity, and we know that electrical pressure is about another name of the voltage, and the answer for this question is about B. What is the unit of electromotive force? We can see that we have A, B, C, D, and we know electromotive force is about the voltage, and the unit of the voltage is about V, and the answer for this question is about A. Hello everybody, so I will do about conversions, and this is on the ASVAB, and we need to learn how to do the conversion of the number. For example, if they ask the nano, we have 1 multiplied 10 power minus 9. Micro is about 10 powers minus 6. Milli is about 10 powers minus 3. And centi is about 10 powers minus 2. Kilo we have 1 multiplied 10 power 3. Mega is about 1 multiplied 10 power 6. Giga is about 1 multiplied 10 power 9. I will provide some example. We have 10 megavolt. We have 10 megavolt. It means that we have number 10 in here. We have the M, that's about mega, so we multiply with 10 power 6, and we have the volt in here. We have V, that's about 10 multiplied 10 power 6. The next one, that's about milli. We have 10 ampere, and they ask about to convert to milli, and we will have about 10. We divide by 10 power minus, because the 10 ampere is higher than the milli, and that's why we have number 10 divided by 10 powers minus 3, so that we have about we have about 10,000 milliampere. Just like we convert the unit without anything to another thing. For example, if we convert to the mega, we just use about number 10 divide by 10 power 6. Or if they want to convert to Ampere, to another anything, we just use number 10 in without the unit anything. We just divide the number in here, and we got about the unit that we want to convert. So the formula to convert is about without, it means without anything in here. A is about Ampere, V is about the volt, omega is about the resistance. We have the number So we have the unit without centimilli or mega giga. So we have the number in here. We just divide the unit that to convert. If we have 10 ohm, but we want to convert to mega, we just divide to 10 power 6. And you got about the mega ampere. If you want to convert to nano, you just divide 10 ampere divide by 10 power minus 9. They convert back to the nano ampere. This formula is so important. So that we need to learn this formula, and we can convert to nano, micro, milli, centi, kilo, mega, and giga. That's it for the physics. As far as electronics, I will ask, what's a kilovolt of 10,000 voltage? We have A, B, C, D. So we see as the voltage in here, that's about, without the unit, we have 10,000. We just divide to the kilo. Kilo is about 10 power 3. And in 10 power 3, it's about 1,000. And we know 10,000 divided by 1,000. We just eliminate 3 zeros. And we got about 10 kilovolt. So the answer for this question is about 8. Question that we ask about, what's the ampere of 0.1 milliampere? In this question, that's a little bit different because they want to convert to milliampere to back to the ampere, and we know that in here we just do the formula, but we now will transfer back to the ampere without the milli, nano, anything. To convert back to the ampere, we have the unit to convert, multiply with milliampere. We know the unit to convert, that's about milli. Milli is about 10 powers minus 3. And we have the milliampere is about 0.1. So we just multiply together, and we got about 0, 0, 0. After we multiply together, we got about 0.0001 ampere. And after we do like this, we can figure out the ampere or the milliampere. So the answer for the question in here is about B. And I will show you another a little bit difference. What is the megavolt of the 10 kilovolt? So in this technique, I will show for you. We have kilo, mega, and giga. In each unit, then we have different 10 power 3 and 10 power 3 in here. So to convert from kilo to mega, we have kilo, mega, giga. To convert from kilo to mega, up to here, we need to divide 10 power 3. From mega to giga, we just divide 10 power 3. But if we want to convert back to giga to mega, we multiply 10 power 3. From mega to giga, from mega to kilo, we multiply 10 power 3. So that's if we want to convert giga to kilo, we multiply to 10 power 6, and kilo to giga, we just divide to 10 power divide by 10 power 6. And this is the technique we learned about kilo, mega, and giga. Similar to the next one, nano, micro, milli. Each of them they have difference between 10 power 3. If we want to convert to nano to micro, we just divide by 10 power 3. And if you want to convert micro to milli, we just divide by 10 power 3. If we want to convert back to milli to micro, we just multiply 10 power 3. From micro to nano, we just multiply 10 power 3. If we want to convert nano to milli, we just divide by 10 power 6. If you want to convert milli to nano, we just multiply to 10 power 6. So this is the way we learn how to convert nano, micro, and milli. This is for the physics. So right now, we have 10 kilowatt, 10 kilovolt, and we want to convert to megavolt. The difference in here is about 10 power 3, but we convert up to higher, so that we need to divide by 10 power 3. So 10 divided by 10 power 3 is about 10 divided by 1000. So 10 divided by 1000 is about 001. And the answer for the question is about C. I will talk about what is the milli of the unit. So we have million, th, thousand, whole number, 10,000. We know that th is about below the decimal. This means that below that the number is below the decimal on the right side, and we know that milli is about 1 multiplied 10 powers minus 3, and in 1 10 power minus 3 is about 1 divided 1000. And in the 1000 we have 001, and you know that 001 in here, the number 1 in here is about 1000 with the th in here. So that's it below the decimal on the right side. So the answer key for this question is about B. I will talk about the Ohm's law. So we have the formula related to the resistance, voltage, and current. This is the Ohm's law, and we have the resistance in here. We have the voltage, and we have the current. This formula will be on the test, and we will learn about the Ohm's law. And we have another formula. If we want to calculate about the current, we have V divided by R. if we want to calculate the voltage, we have I multiplied with R, so that we have the two formula we need to learn. If you forget about the formula, I will show you about this one. This one is about the triangle, and we know that if you want to calculate the V on the top, I and R will go together. That's why we multiply together, so that we have the base to support for the voltage. If we want to calculate the I in here, the I in the small one in here, so that we have V divided by R, so that we got I. If we want to find the resistance, we have the V divided by I to get the R. This formula will have co-relationship, so that if R go up and I are same, so that V will go up, because R go up but I don't change anything, so that V will go up. If R go up and V did not change anything, so that I should be go down. So that we can say about conclusion. In the conclusion, we know that R and V, they have positive relationship. If R go up, V go up. If R go down, V go down. And R and I, they call about inverse relationship. For example, if R go up, if I will going down. If R going down, I going up. So that they have inverse relationship in the Ohm's law, and this is the only information about the Ohm's law. So that's we need to learn. We need to learn to apply for the exam. On the question that we ask, what's the Ohm's law? On the real ASVAB, they asked about what is the Ohm's law, and we know that the answer for this question is about another way to ask like this. So another way, what is the Ohm's law? So we can see that they just involve I and R together, but they still the Ohm's law, and this is B. Sometimes they will convert or switch about I, R, U together, but you need to know that we have three formulas. This is means And you know that in this question we must know three formula, because sometimes they change or switch about the R UV together. We don't know about the formula because many students they just concentrate about R equal V divided by I, but they don't know that we have another two formula, that's about I and V. So if they ask about this Ohm's law, three formula will be the correct answer. In the test, they will ask what is the current of resistance is 20 ohm and the voltage is 100 voltage. We have the formula for the current. I equal to V divided by R. We have V is about 100 and we have 20 and we got about 5, 8. So the answer for this question is about 8. What is the resistance of the circuit? And we have the picture on the test. They will provide the picture like this and they ask you to calculate anything. So we have 20 volt is about V is about 20, I is about 5. So right now we have about 20 and 5. We just apply the Ohm's law. It's about we have V and we have I for the current, V for the voltage. So we have V in here is about 20, we have 5 in here. So that's the resistance for this question is about 4 ohms. And the answer for this question is about 8. We will learn about different kind of symbols, and this is on the ASVAB electronic information. They will ask about what's the symbol of them. So I will follow some one by one. First, we know that there are two types of resistor. They are called resistor. That is about just like the wavelength about the long rectangle. They have the rectangle and the wavelength. We can call them about the resistor. The next one, that's about variable resistor. And this is on the ASVAB. Sometimes they will call about rheostat. Rheostat is about variable resistor. This is similar to same name, but they have same object. The next one, some people confuse. They thought that that's about the resistor, but actually that's about the fuse. And this object is when the high voltage, or maybe when we use very high voltage with the high current, the fuse will break the current inside the fuse and they will stop the high voltage. Maybe about the short of the electrons. At the same time, the fuse will do this job to disconnect the circuit so that we don't have the explosion in the short circuit. The next one is about the light, or maybe about the both light too. Two objects in here, they have the same. For example, they have the circle with the cross S and another circle, but they have the omega inside. That's it about the light or the both light. So we have the same purpose too. The next one, that's about voltmeter. The voltmeter, that's about calculate about the voltage. This one about the Ampere meter, they calculate about the current. This one is about the battery, we just draw many times. The long one should be the positive side, the small one should be the negative side. This one is about the transformer. This one to convert the high voltage to the low voltage or vice versa. If inside the transformer they have this is about the iron core. This iron core just used for the transformer. The next one that is about capacitor. Capacitor is about they store the electrons inside the capacitor. Diode for this purpose they just put the electron go one way and they cannot turn back. That's the purpose from the diode. The next one that's about inductor. Inductor just like the spring that just go up many times like this. That's about the spring. Be careful about this. This is a transformer. If there are two springs together, in here only one. Be careful between the transformer and inductor. That's the mistake. When on the test they put the transformer, but the student they choose about inductor. That's incorrect. So we have one, it should be in inductor, and transformer, it should be through spring. The next one is about the round. This one for the round when we use for the antenna. On the top one, if we have the thunder light hit on the antenna, that will transfer the electron go to the round, and we can save the object in here, because if we have too many electrons on the wire, they will explode, because this is about the high voltage. This one is about the transistor. This is on the test, and we need to learn about the transistor. And there are so many symbols. I will put the link over there. Therefore, you can learn another symbol.